Okay, we are now recording. So current, and actually, give me one sec. I actually do need to pull up the answer key for that one. Actually, I can look at my phone. It's fine. Because I want to make sure I'm getting all the terminology straight here. Give me 1 second. Okay, here we go. So what is a current? It's the rate hold on, why is it not, there we go. Okay, it's the rate of flow of charge. So we kind of talked about that in the Google form. Or its amount of charge per unit time that crosses one point. And that's the form right there, where I is current, Q is charge, and T is time. Excuse me. The symbol is I, of course, and the unit we call it ampere. I think it's probably named after the person who kind of discovered this. So that's just some stuff there. So let's look at this one here. Small computer speakers often have power supplies that give 12 VDC, not sure what that really means, at 200 milliamperes. How much charge flows to circuit in 1 hour? How much energy is used to deliver this charge? We haven't talked about energy for electricity yet, but we would probably do this one here. So I'm not sure what this means. I think they probably meant 12 volts as a direct current, but I really want to focus on this. And that's about how much charge. Remember, I equals Q over C, or Q over T. And it's milliamperes. So you're actually going to write it as 0.2 amperes. And times 1 hour, you want to convert that to seconds. So you solve for Q. I can let the 720. Coulombs. And a coulomb is a measure for charge, just so you know. Sometimes we use capital C. So I know I'll kind of give you a crash course on some of the stuff here. But just know Q represents charge, or the amount of charge that a particle has. Let's keep moving here. Okay, let me undo that. Excuse me. Electrons are the charge that flows through wires. So that's what we expect. And that's why we see, electricity kind of flowing through all these things we have in our lives. Historically, it was thought they were positive charges. But they're really negative. So they're, negatively charged chemistry. Probably learned about that. Conventional current. Is basically the imaginary flow of positive charges. And it flows from a positive terminal of a battery. You can think of a battery, sometimes you can do that, to a negative terminal. And real current flows the opposite way. So just some literature stuff on this here. And I won't really be assessing on this stuff, just so you know. I just want to just go through it. Electrical signals. Travel near speed of light. So electrons are moving really fast. Sorry, electrical signals, but electrons travel much slower. Each new electron pushes one ahead of it. So current is actually like a wave. And it's some wacky formula here, but I'm not going to really worry too much about it. Actually, yeah, we won't worry too much about it. Just cross it off. I care more about Ohm's law and current. So I'll give you guys a chance to copy all that rest of that down. So again, electrical signals travel near the speed of light, but electrons travel much slower. Each new electron pushes one ahead of it, as you can see right here. So it's kind of like a wave, kind of all over the place. Don't worry about that formula. I cross it off. I don't really care for that for this class. Okay. Unclear. So let's discuss about Ohm's law, and then I'll do a practice, then I'll have you guys try some problems on your own. And hold on a sec here. Okay, so Ohm's law, I equals V or R, V equals IR, same thing. V is voltage. EMF, just so you know, stands for electromotive force. So it's kind of like how much charge is coming through. Current is the charge per time, and they have resistance. The unit, when you do voltage over amperes, It's called an ohm, and just discovered by some guy with that name. Device that offers resistance to flow chart. That's what a resistor is. By the way, light bulbs have resistance, just so you know, because it's not if it didn't resist flow chart, it would probably break or overheat. Copper wire has very little resistance. You might hear how when homes are being constructed, homes are abandoned, people will go into the walls and take the copper wires because that has value. Because that's what really what's the electricity flowing through your house will have 10 of copper wires. Symbols used for resistor is right here. All my years, I've always been very messy in drawing those. I probably should take my time drawing nicely. Yeah, see, I just struggle with drawing it. So, and so here's your voltage supply. Or you call it your power supply. So it's kind of like a battery. Think of it that way. You have current flowing, you have a resistor. That's what we got. So speakers have volume 200 milliamperes at maximum volume. Voltage 12 volts. Current is to produce a magnet, which is used to move the speaker cone. Find resistance. So, really simple. V equals IR. 12 equals 0.2. Solve for R. The resistance is 60 ohms. That's it. Really easy stuff. So you guys are just kind of getting acquainted with this. So, any questions about what I've done so far? Nope. Okay. So we'll put you guys in breakout rooms. We'll do 4 breakout rooms. And I do have to just grab some things from my office because house cleaners are here. So I'll have to hang on the backyard, which I'm not complaining. I have a nice backyard. So anyway, let me clear this. Stop sharing. No, we'll keep sharing. I want you guys to start with number 6 and go all the way to 17. So you guys are going to be doing 12 problems. I think 15 minutes should be sufficient. By the time we get to 10:50, we'll talk about it, then we can move on to another topic. I think most likely, sorry, I lose my voice. We'll talk about this stuff here. And then I think after that, probably want to get into circuits. That's kind of fun. Don't know if we might be able to hit that up because it does kind of tie in close with some of the other stuff we've done. We'll see. Don't know if we'll do 9.4. Well, you should know about electricity being dangerous. We'll see. But for sure, we'll do 9.2 today, and probably 9.3 or 9.5. But anyway, for now, for 9.1, I want you guys doing 6 or 17 in your breakout rooms. 6 or 17. Set this up. Do 4 rooms. Options. Sit there for 15 minutes. And you guys will go.